So for us, where do we leave off at, guys?
We're on 27.
27. We're on 28.
Do 27.
Okay, so here we go. Yeah, just relax. Everybody take a look at 27, just to make sure.
670.
All right. We said it was about 672. Well, we said it was 672 square feet. Does everybody agree with that? All right. Now, 28. Here we go. All right. Everybody take a look at 28. I said you didn't really have any homework. All right. So, listen, here's what I want to do. I'm going to put it on pause. I'm going to give you, let's say, 10 minutes to try 28, 29, 30, and 31. All right, you got 4 problems to do. All right, what? Yeah, I know some of you weren't listening. All right, and I do appreciate you guys. You did it. All right, I don't mind. So then just review your formulas. All right, review the formulas we've already done. Those of you guys who don't, just now for 28, it says the Acme Canning Company produces cans for chicken soup. If each can has a diameter of 2 inches and a height of 3 1/4 inches, how much aluminum? All right. How much aluminum is needed to make 1 can? Round to the nearest hundredth. All right, so what are we talking about here?
So,
Finding what?
we try to find the surface area.
Yes, that is correct. Thank you. So what's the formula for that?
2 pi r squared plus 2 pi r.
Very, very nice. Thank you.
And
Good
that
job.
gives you squared forward.
Wait a minute. I want the radius, though.
The radius is 1.
Good.
Which is the
What's the height?
height is 3 1/4.
Okay, buddy. Come on now.
Total is 26.7.
And then we would say inches square. But somebody else has to confirm that.
Yeah.
Everybody happy with that?
Yeah.
All right. Honestly, now listen to me, guys. If you got that right, all right, you're in pretty good shape. All right, you're in pretty good shape. You understand you're looking for a surface area of a cylinder. You know how to plug the numbers in. All right. And like I said, I'm hoping you don't have to look at the formula sheet every time you want to look something up. All right. Hopefully you have a pretty good idea. All right. Now, number 29, a little bit different, though. All right. Everybody take a look at 29. Who wants to give me an explanation on 29? All right, Mr. Danzy, tell me what to do. Not the answer. Tell me how to solve it.
First, you need to find the surface area of your border,
Right?
which would be,
Something, but then what?
and then once you have that, you do that times 10.
Why?
Because it's 10 barrels.
That's correct.
And divide by $2.60.
And then divide by 260. Anybody else agree with that?
Yeah.
Anybody else do it differently? Hint, hint. You may do it differently. Tell us.
So I did about 29.16. That's like 260.
I'm not understanding. Did you understand? Did you hear what he said? So I'm asking you, how did you do it? I don't want the numbers. I just want you to tell me how to do it.
I got the surface area, I multiplied it by the price, and then multiplied that by 10.
Yes, your one mistake, Mr. Danzy.
Oh, yeah.
Are you dividing by 260?
No, you're doing the first 260.
You're multiplying by 260.
Dividing it by 4.
All right? Because it's 260 per square foot. That means for every square foot, it's going to cost you $2.60. All right? So, again, thank you, Alden. Let's agree, surface area of the barrel. What would be the surface area of one barrel? Alden, did you tell me the surface area of one barrel?
29.16 squared.
29.16 square feet. Does anybody else get that?
13.30.
Uh-oh. So again, surface area is equal to 2 pi r squared plus 2 pi rh. So what's the radius again?
1.125.
1.125 squared plus 2 pi times 1.125 times, what was the height? What was the height?
3.
3. All right, so everybody do that real quick. Double check yourselves because we got a couple different answers.
I did that way, but on the formula it's flipped. Down the
Yeah,
formula.
it doesn't matter. It doesn't matter. Doesn't matter because it's addition. All right. So again, I need help. I'm asking, what's the surface area of one barrel? How much?
29.
Somebody said 29.16.
That's what I got. 28.99.
Okay, 28.99. It doesn't matter to me on that either. All right. And now, how many barrels are there? 10. So we multiply that by 10. So that's roughly 291.6 square feet, right? And then multiply that by what? Multiply that by 2.6. You should be spending roughly how much?
$753.
Roughly $753. Does anybody agree with that?
I got $758.
Okay, I'm not arguing with you. All right, that's close enough for me. 753. If you're right around there, I'm happy with that. Yes, what? All right, anybody have any issues with that? What?
I'm still confused why you times it.
Because let me just make this, see if you understand this. Shh, listen, so I can explain it to you. Do you agree there's about 292 square feet? Each square foot costs $2.60. So if you have 290 of them,
Oh, okay.
you with me now, right?
When do you divide them?
Well, it's hard for me to say when you divide. Because each problem is a little bit different. You with me? That's why I'm saying I really try not to. I really am trying to prevent you from memorizing. That's why I put so many different types on here. All right, I'm expecting you to think about it. All right. So again, let's look at the next one. Oh yeah. This one was kind of tricky. All right. So some of you may not know this. So if you made a mistake on this, it's okay. All right. Tell me, what are we doing?
So we have to get the surface area of both of the pipes, and
Exactly.
then whichever one is biggest needs more in insulation.
All right, so hold up a second. So I'm going to draw the pipes. All right, hopefully everybody was able to draw the pipes. So I'm going to draw this pipe right here. All right, and then here we go. Right here. All right, there's my pipe. And what did we say the radius of the pipe was? Help me, guys.
Radius of the pipe was 1.5.
Was 1.5. Stop talking. And what is the height?
30.
30 inches, right? So we agree with that. So now the question is, we're going to put insulation around the pipes. Now you got to look up. All right, I'm not expecting you to know this. All right. If I put insulation around the pipe, all right, I'm trying to put insulation around the pipe. Now the question is, do I put insulation here and here?
No. Ew.
All right.
That's
So I don't. Again, that's pretty good because. Do anybody know why you put insulation around pipes? Tell me.
To keep it,
Keep it what?
so it doesn't water. Nice and warm.
Yeah. Okay. So does anybody know water has an interesting characteristic? It's one of the few things that when you freeze it, what happens?
it's solid.
Yeah, it does become a solid. But what happens?
It stays the same. It's cold.
If it's cold, then it's
So somebody tell me this: when you put a soda can in your freezer,
it explodes.
why does it explode? Is what the question is. Why does it explode? That has nothing to do with pressure. What does that have to do with?
Coolant temperature.
What
It
ha-
expands when it
Yes, exactly right. You guys should know that. All right.
I
When
knew
water freezes, it does what? It expands. All right. So if you put a can of Coke into your freezer and it freezes, the reason it explodes is because the water inside is expanding and it can't fit inside the can anymore. All right. So it eventually bursts out. All right. Same situation here. Up north, we live in the south, so we don't really get cold temperature. But up north, all right. No, you're not doing this to me anymore. All right. Just stop. up north, they insulate the pipes coming in that carries water. Why do they do that?
So it doesn't expand.
Yeah, if it freezes and the temperatures up north can get very cold, the pipes freeze. And if the pipe freezes and there happens to be full of water, what will happen to the pipes? That's what they're talking about. The pipes will burst, all right? Because there's frozen water inside the pipe, all right? Same situation here. We don't put insulation at the end. So we really are just interested in what type of area here. What's it called? The area around it.
Lateral.
The lateral area. Thank you very much. We're interested in just the lateral area. The surface area is the bases and the sides. The lateral area is just the what? Is just the sides. All right? So here is the first pipe right here. Am I interested in the bases?
No.
No. So I just want the perimeter times the height. Good. So I want everybody to write down perimeter times height. But the perimeter of a circle is the what? Circumference. So you should be able to tell me that that's just 2 pi r times the height. 2 pi r times the height. We don't need the bases. We do not need the bases. Because we don't need the bases, now it's going to be 2 pi. What's the radius again? 1.5 times the height, which is 30. Do me a favor. Go throw that in the garbage. All right? Right now. What? Of course it can be pi d. All right, of course it can be pi d. I don't care. All right, you know, 2 times the radius is the same as pi times d. All right? So now, somebody tell me what that amount of insulation I need for the first pipe is. 282.73 square inches is what someone's telling me. Come on now. I'm not interested in those little the rounding. All right, I'm interested in if you're close to 282. Everybody okay with that?
Yeah.
All right. Now it's the same principle. We have the other pipe now. All right. The other pipe is the same exact thing. It's going to be 2 pi r times h. So what's the radius of the other pipe? What's the radius of the other pipe, guys?
About
No. What is the radius of the other pipe?
Oh.
3. What's the height?
12.5.
12.5. All right, so tell me, what's that roughly the insulation I need? 235. 235.6162, whatever, inches squared. All right. So right now we're going to need more insulation on what?
First pipe.
First
pipe.
Right.
I just do mine on the box.
No. Okay, so the one that has a radius of 1.5 and a height of 30. Yes, sir, I'm listening.
Wait, okay, so
Hey,
if you only insulate the outside, wouldn't you just need the surface area?
so what does that mean?
Well, the surface area is the area of all the outside.
Yes, I'm agreeing.
Bases and
But I'm saying to you right here, this is the shape I have. And again, I'm trying to help you so when you take your test, there's going to be some unique questions. I'm trying to get you got to think about it on your own. All right. So here's the pipe. This is what I was trying to tell you. All right. If this is the pipe right here, am I insulating this part of the pipe is what I'm asking you. Am I insulating that?
No.
No. So instead of it calling the surface area, we could call it the what?
The lateral.
The lateral area. I'm trying to teach you the math terms. It's called the lateral area. But I don't even care if you call it the lateral area. I just want you to say just insulating what's around the pipe, not the actual ends. That's all I'm asking. And that area is the perimeter times the height. And the perimeter we were talking about is the circumference of the circle. All right? So here we go. Next, number 31. It says the Good Time Company needs to make paper hats. All right, so this is another one. Very interesting problem I need you to think about, and it's easy to make a careless mistake on this. All right? So you are going to make a paper hat. that is in the shape of a cone. The radius of the cone is 8 centimeters and the slant height is 20 centimeters. All right, so if you are going to make a hat in the shape of a cone, all right, let's do this. Let's make the hat. Does everybody agree that's my hat?
Yes.
The question is, when you make that hat, all right, are we calculating this surface right here?
No.
No, we're not. If you calculated that surface, I don't really care. I'm just telling you, you're not thinking about it clearly. All right, when you put your hat on, all right, there's got to be space for your head. All right, so there is no space here. There is no space there. All right, so again, we're just calculating the what? What is that called again? Lateral area. Come on, guys. I'm interested in calculating just the lateral area. All right, Oscar was correct. We don't need the area of the base. All right, so to calculate the lateral area of a cone, what is that formula?
2 pi r.
No.
2 pi r L.
Say it.
2 pi r L.
Yes. 2 pi r L. That is the only part of that hat that I have to find the area on. All right, so again, what's the radius? Somebody help me.
8.
8. So it'd be 2 pi times 8. What's the slant height? 20. So altogether, I need how many?
105 or 1,000.
Somebody said 1005 approximately centimeters squared. All right, 0.31, I'm okay with that. All right, roughly 1,005 square centimeters. Go.
Why do we times it by 2?
What is the formula?
Well, I thought the formula
I'm just asking you, what is the formula?
I thought the formula was pi r squared plus pi r L.
Because you didn't listen to the whole conversation. You even said, do we need the area of the base? You're the one who brought that up. I even gave you credit in the video.
With the
So do we need this area right here, Oscar? That's the question. You already said no. So your answer can't be correct. It's not pi r squared plus pi r L.
yeah, but
It's just what?
2 pi.
Oh, somebody did. We did make a mistake.
I thought it was
Pi r L, not 2 pi r
Oh, sorry.
L. Uh-huh. Max, you sounded so confident. I believed you. And then I had to fuss at Oscar because I thought he wasn't listening.
Also, because
Thank you.
Oh my God, Oscar's actually right.
Because it's 1/2 perimeter times the slant height.
Come on,
All right. So change that, please. The surface area is 502, about 502 centimeters squared. All right. Thank you, Oscar. All right. Does everybody see that? All right. Here we go. Let's have some more fun with question number 32. All right, so on question number 32, it says, Audrey uses a metal scoop to measure the correct amount of food to give to her horse. The scoop is shaped like a cone, and its dimensions are shown. So now, I'm trying to calculate how much metal there is on the scoop. So once again, you have to be able to tell me. All we're doing is the lateral area. So Oscar is going to tell us, what is the lateral area for this cone going to be?
Pi 3 and times 8 and 1.
Pi times 3 times 8.5. I was hoping you would say pi RL. That's exactly correct. So everybody do pi times 3 times 8.5. And tell me that's rough.
That is 80.11.
About 80.11 what? Square inches. About 11 points or 80.11 square inches. All right. So now each one of these questions require you to think about how much of the shape, all right, do we need? All right. So what I want to do now is I'm going to put it on pause. What time does the bell ring?
37. 27.
All right. All right, get busy on the next 3 or 4 questions. Shh.